Okay, well, we'll begin. Sorry, I have this is all titled wrong. I guess I copied and pasted and didn't adjust and things. So anyway, well, I'm back from PyCon and I had a great time out in Pittsburgh. Exciting stuff. I don't know. I feel like I learned a lot. There's a whole bunch of cool packages and things and developments and the world of Python. Yeah. Anyway, it was great to be there. Python, by the way, is open source software and it's kind of it depends on like sponsors and volunteers. It's not a commercial entity, so we use Python for free and all of that. So thankfully there's like corporations like Amazon and Microsoft and Meta sponsor the Python Software Foundation. But also relies on kind of the community and all of that. Anyway, interesting talks. If you get a chance to attend Python conference, PyCon, I recommend it. If you find yourself at a job, ask your company to send you. And actually, so next year we'll be in Pittsburgh again, but then in 2 years it will be in Long Beach. So that's not too far away. And if you are a student, you can get academic pricing for registration and things like that. So, I mean, most of you will all be graduated by then, but perhaps you will still be a student, and you can attend, or perhaps your company, your place of work will send you. Okay, we've been working on object-oriented programming, and we saw. I think the last time we talked, we had a bunch of like methods and kind of these double underscore methods that were pretty cool, that kind of extended the use of our methods. I think we saw like, oh, you can have the plus operator, by having double underscore add and things like that. I want to keep talking about inheritance, and we are going to do kind of this application that looks at poker. Oh, by the way, I've just posted homework 5, your last homework assignment. Wait, is some?
Oh no.
No. Okay. So this will be your last homework assignment. There's a few things. The last bit, the last chunk on homework 5 is fairly time consuming. Okay. It's a poker hand probability calculator. Okay. Or simulator, I guess. It'd be your quote monopoly of this class. But it's but I think it's interesting, and in my opinion, I think it is satisfying when your results end up matching like what Wikipedia says it should be, right? So on Wikipedia, there's a page called Poker Probabilities. Okay. Maybe I have to do a little bit of maybe some of you have never played poker, so it's this card game, right? And you're looking for, I guess, certain hands, and so you might need to do some reading about the different poker hands that are out there. Okay, and so we will look at 7 card poker hands, which will be you're dealt 7 cards. Out of those 7 cards, you look for the set of 5 cards that have the highest rank, okay? And so, the highest ranking thing that you can get is the straight flush, okay? Of which the royal flush is the most powerful of the straight flushes, okay? But then you have the 4 of a kind, full house, the flush, the straight, 3 of a kind, 2 pair, 1 pair, and no pair or just high card, okay? And Wikipedia lists off all of the combinatorics. Is that how you do it? For the absolute frequency to get all of these things, okay? So there are mathematical analytical answers to do this, okay? We are going to do the Monte Carlo approach, all right? And so we will write, well, not we, you, your homework will require you to write some stuff to do some simulate poker hands and evaluate poker hands. And then, and at the end, you should end up getting probabilities or odds that are, kind of similar to what is listed by Wikipedia here. Okay, and it, when that happens, I think it's kind of a satisfying experience. So anyway, that's that. Okay, we are going to take a look here. The way we'll create poker hands is just a touch different from the way you'll create poker hands in your homework, but anyway, it's all object-oriented programming and whatnot. So, all right, let's introduce this topic: inheritance. Okay, inheritance is the ability to kind of define a new class that basically builds off of an already existing class, right? So you have an already existing class, and then you build a new class that's kind of like a modified version of that thing. Okay, and so we're going to create classes to represent playing cards, decks of cards, and poker hands. So first we're going to create something to represent a card object. So in a standard we call this a French deck, you have 52 cards. You have 4 suits. They are spades, hearts, diamonds, and clubs. Sometimes people call them clovers, okay? And that is the ordering of the suits is arbitrary, but in the game of bridge, they are ranked, and that is the rank. Spades is the highest ranked, hearts is next highest ranked, then diamonds, and then clubs. Okay, and then you have 13 ranks, ace through king, 1, 2, 3 to 10. Jack is 11, queen 12, and king 13. I guess would be the value. And so 4 times 13 is 52. You have basically 1 card of every possible combination between suit and rank. Okay? And so if we define a new object to represent a playing card, you basically need these 2 attributes, the rank and the suit. How should we store these things? Well, we will store them in a new class called card. Okay? So here it says if you use strings to store these things, it would be difficult to do comparisons. And so what we'll do is we'll encode everything. And so we'll encode the suits going 3, 2, 1, 0. Okay. And then for the ranks, we'll use their numeric values, but 11, 12, 13. And so here we'll define card class. And then when we initialize an instance of card class, we will store self.suit and self.rank, okay? And by default, we would have clubs and rank 2. This would be kind of our 2 of clubs would be the default. So here, if we wanted the queen of diamonds, okay, we would say suit is 1, rank is 12, okay? And that's how we could define that. Let me restart and clear all of my outputs here. So I'll go ahead and do that. Okay, and then if we want this to be easily read by humans, then we will kind of implement, we could implement the print method. So right now, if I just say, hey, what does Queen of Diamonds look like? Okay, we just get, this is currently how it gets produced. It says we have a card object, an instance of the card object here, okay? Here, I'm going to use something called the double underscore string method, double underscore string. So this is going to be like when we call print, how should it look? And so when we call print on this, we want it to say, it looks like Queen of Diamonds, right? So we want to put in rank of suit. So the double underscore string is going to give me what it outputs when we call print on Queen of Diamonds. And so basically I will take this list and we will kind of subset it to the numeric rank. And then as far as numeric suit. And then for the rank names, we're going to go we'll list off ace through king. There's no rank 0. Okay, so I'm just going to plug in a none into the rank there. Okay, and so now if I put in define here, now we can create a card, and then I can call print on the card, and we will get Jack of Hearts. Okay, so if I say here's card 2, 11, and so on and so forth. Okay, so this is Ace of Diamonds, 6 of Spades, and things like that. Okay. We can put in a method for comparing things. Okay, we did not do this, right? For the time, we didn't have we only had the add operator and the right side add, but we saw like it. But once you put in double underscore add, you could do things like sum. Okay. Similarly with Python, you can do a comparison operator. So here we have double underscore LT. Okay. And we have double underscore EQ. So double underscore LT for less than, and then double underscore dunder EQ for equality, test for equality. And so what we'll do is we will test for less than, we will check self.suit and self.rank, okay, and then other suit and other rank, and we will see if one is less than the other. So we'll look at ourselves, and so this is an arbitrary choice, but we're going to basically create tuples out of the suit and the rank. And here we're going to put the suit as more important than the rank. So that's an arbitrary choice. You might say, no, like I guess I'm thinking like if you sorted the deck, if we said sort the deck, you'd probably put all of the spades together from ace through whatever, and then you'd put all of the hearts together, then you'd put all of the diamonds together, all of the clubs together or something. Versus you could tell somebody to sort the deck, and then they might go ace, 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 and then 2, 2, 2, 2, 2, or whatever, 3, 3, 3, 3, and they put all the numbers together. Those are both valid sortings, but here we're going to say suit is more important than rank. So we'll put all of kind of the aces together. I mean, all of the clubs together, all of the suits together, and things like that. So here we're creating a tuple with suit and rank for the self, tuple for suit and rank for the other. And if tuple 1 is less than tuple 2, remember these are just integers, right? Self.suit is an integer 0, 1, 2, 3, and self.rank is an integer 1 through 13. We're going to just compare that. And then double underscore EQ is a tuple, and we're going to just kind of return the result of is tuple 1 equal to tuple 2. Okay, so here I will create card 1, Queen of Diamonds. Card 2 will be Jack of Hearts. Okay, we're going to ask, is card 1 less than card 2? Okay, and now we're going to get true because diamonds as the suit is ranked lower than hearts. Okay, if I create card 3, which is the Queen of Hearts, we can compare Queen of Hearts to card 3 being Queen of Hearts versus the Jack of Hearts. And that one is false. And card 4 is another, card, I'm losing track. So card 1 was Queen of Diamonds. Okay, card 4 is also Queen of Diamonds. So here I can say, is card 1 equal to card 4? Okay, and that is true, right? And remember, equality is not the same thing as is, right? So here oops. So if I say card 1 is card 4, that's false, okay? Because the true value of card 1 is it is an object here, and card 4 is an object at a different memory location. So they are not the same. Card 1 and card 4 is card 1 is not card 4, but is card 1 equivalent to card 4 as in the test of equality? That is true. Okay, so we understand the difference between the is operator or the is thing and the double equals test for equality, right? Okay, card 3, Queen of Hearts, is Queen of Hearts equivalent to Queen of Diamonds? No, that is false. Right, so we have these comparison operators. Okay. Here we're going to create a class that contains or holds cards. Okay, so now that we have cards, we're going to define a deck. A deck is made up of cards. Okay, so we're going to basically create the deck to be a list. Okay, and within the list we'll put in the cards. Okay, so my initialize method is going to create basically an empty list called self.cards in the deck, and then what we'll do is we'll run this double for loop, and basically for the suit in the ranges and the ranks in range 1 through 14, basically we'll create a card of that suit and rank, and then we will append the card to the list self.cards. Okay, so that will create 52 cards, and we'll append them all into this. And then when we ask to print out the deck, we will go through every card in this list, self.cards. We will ask for the string representation of the card, and then we will append it into a list. The result here is going to be a list of strings, and then what we'll do is we will just join. We'll do /n.join. This is I guess like a little Python idiom for basically just print out everything in the list with new lines to separate them. If you did space.join, then it will print out everything in the list separated by spaces. Okay, so so here I will create a deck, and then when I print out the deck, we get the entire list of things, right? So Ace of Clubs all the way through King of Spades. But yeah, if you do say like comma space join here, then you'll get the full kind of list there. But this is a handy little idiom here. You just say like, hey, just join that /n with every basically every entry in your list there. So there are your 52 cards there. Okay, we'll create a few additional methods here. Okay, that allows us to kind of work with the deck and manipulate things. Oh, let me give you. Oh shoot, I gotta find my. Okay, sorry. I'll try to talk and look up the Viqua's answers at the same time. Okay, so we want to define a few methods. Pop card, basically that's going to be just dealing off a card from the deck. We'll just kind of pop the last card from the deck, and so that will return a card, right? And then that will reduce how the number of cards left in the deck. Okay. We can also add a card. So assuming we get a card object, we can append that card to our list of cards. And then we can do shuffle. Okay, so random.shuffle will take an iterable like a list, okay, and then shuffle the contents of that thing. Okay, and then, and this is what I think is really cool, is because the cards have this comparison operator, we can call sort on any kind of list that contains card objects. So now that we have a way to compare one card with another, if we have a container that contains cards, we can sort that container, okay? And that is powered by the fact that this less than operator exists. Okay, so we've added all of these things. So here we're gonna define deck. We do need to import the random module to get this to work. Is that right? Okay. All right, your first view quiz answer is the letter A. All right, so let's try this out. So here's my deck. Here I can ask, okay, how many things do I have in my deck in deck.cards? Got 52. We'll print out the deck. This is what it looks like. Here I can shuffle the deck. Okay, and then I can print out the deck, and you can see it got shuffled. Okay. I can pop a few cards, okay? 2 of diamonds, it's basically dealing off the bottom of the deck, okay? 2 of diamonds, 2 of clubs, okay? So how many cards do I have left? Now I have 50 cards, and then if I say like print out the cards, you can see those 2 cards are gone, but you know the rest of the deck has remained in place. I can also do deck.sort. Okay, and then now I can print the deck. All right, and when now that we've removed those 2 cards, what was it? 2 of diamonds and 2 of clubs. You can see they're missing from the deck. 2 of diamonds and 2 of clubs are missing after I've sorted them. So all of these things indeed work. Okay, so those are all of these things. So the sort I think is cool because you know our cards can be compared to one another. Okay. All right. So let's define a hand. A hand is going to inherit from a deck. Okay. So a hand is basically like a smaller version of a deck, right? So if you think about like if you're playing poker and we deal cards out, each person gets a hand, which is basically like, oh, now I'm holding 5 cards. And it's like a miniature version of a deck in that they are collections of cards. They have operations like adding cards and removing cards, okay? But it's also different in that like when we initialize a hand, we don't want to have 52 cards going into it and stuff like that. And then, you know, we might want to have a way to compare one hand to another or evaluate your hand, which is what you're going to have to do in your homework. You want to be able to say like, okay, given this collection of 7 cards, what is like, how do we evaluate this thing, okay? So here to say that the hand inherits from another class is when you define your new class. So here we're defining class hand, okay? In the parentheses, I put in capital D deck to say that it inherits from deck, right? So compare that to like over here, when we define class deck, we just write class deck and there's nothing there, okay? And here we're gonna say class hand, and we put parentheses deck. And that's going to say, all right, we're going to create a new class. This thing inherits from the deck. And normally you would then put in all of this stuff. So, so here we're going to change, one way we're going to distinguish the hand from the deck is that we're going to say, when we initialize a hand, it's going to come in with an empty list of cards, and that will be it. Okay, so I guess when you sit down at the table for a game of poker, your hand starts off empty, you get nothing in there. Okay, we'll also put in, I guess, a label, just so we can say, hey, this is, you know, the new hand, or this is my hand or your hand or something like that. Okay, so we'll put in a label as one of the arguments there, and that will be that. Okay, basically anything that you define in your class that inherits will override the kind of the parent, the methods from the parent class, and then anything that you don't define will just kind of inherit. Okay, so the child class, the hand, will have a different initialization, but all of the other things that were defined in the deck class, like add card, pop card, shuffle, and sort, those will all get inherited. Same with string, the string method to do that. That will get defined there. Okay. So so here we'll have here we'll create a new hand, and I'll ask for hand.cards, and that will be an empty list. The hand.label is new hand. Okay. And then so what we can do is here I'm going to create a new deck, and then we will transfer one card from the deck to the hand. Okay, so I'm going to say deck.popCard. That will be my card here. And then here I'm going to add a card to the hand. I'm going to do hand.addCard, and we'll put in the card. Okay, and here I have this written across 2 lines, I guess for a little bit of readability, but you could see that it can be just done in 1 line, right? I could just do hand.addCard, and what are we going to add? We're going to add deck.popCard. Okay, and so now remember we initialized the deck with all 52 cards and we didn't shuffle it. So what is the card that's going to be in this hand? It'll be the last card that was in the deck, which was the King of Spades. Okay, and then we can kind of do stuff like that, right? So if we wanted to kind of make this a little bit more efficient, okay, we can create a method in the deck class called move cards. All right, and so move cards will be a method that takes into as an argument a hand, okay, and then how many cards, the number of cards to move, okay, and then we will just kind of repeat that process. So we'll say for I in range number, what are we going to do? We're going to take the hand, we'll add a card, and what are we going to add? We're going to pop a card from the self. Okay. So I don't know. I feel like there's an elegance in writing Python like this, right? In using kind of this object-oriented style, having these kind of things that call to itself and transferring, like we're going to add a card by, basically popping a card from itself, okay? And so that's what we have here, okay? And we didn't have to redefine add card because it just inherits that method. The hand inherits that method from the deck class. Okay. The warning though is that inheritance, like when you do encounter problems, it can be a little bit trickier to debug because it's like, whose fault is this? And it's like, oh, it was in the parent class. You're just like your father or something. Okay. Yeah, so problems like that. Okay, so we got deck equals, we're going to try this again. Okay, we're going to create a new hand. And here we're going to move 5 cards. We're going to do deck.move cards to the hand. We're going to move 5 cards over. So we're going to print the hand. We have a royal flush. Not quite. almost straight flush, 9 through king of spades. Still a very good hand. Okay, and then we have that. Here we can also take the deck. We can shuffle the deck. Deck.shuffle, and we can look at kind of the last 5 cards here. I can say, hey, move five cards from the deck, and we can see, okay, yeah, those 5 cards got moved, and now what's at the deck? Obviously, just the the cards and whatever. Okay. Okay. Class relationships, class diagrams are useful. Oh, okay, so here, objects in one class might contain references to objects in another class, and so this was like the deck contains cards. That's a has a relationship. Rectangles contain points. Rectangles have a point. Okay. Class is inherent from another. That's an is relationship. Okay, so a hand is a kind of a deck. Okay, and then one class might depend on another class, and these kinds of things are just kind of dependencies. Within an object, you can also ask for the variables or the attributes that exist by calling vars. Okay, and so here within var's hand, we get, it says we've got cards, and then it lists off all of the card objects there, and then there's a label, new hand there. Ooh, let me, okay, there's something I left off. Oh, okay. So when you look at this is hard to read, right? So you look at cards, and it comes out as, so we have a method. We have the str method. So when I look at, like, say, within the deck, okay, deck.cards, we have all of this thing, and I can say, like, what is the kind of the first card here? We get that, and I can print this, and I can see it. So I can call print on what is inside here, and I can see what that is. But if I just do deck.cards 0, it's like, this is impossible to read. Okay, so there is another method, not just the string method for when we define cards, okay? But there's something called the representation method. So I'm going to copy this. Okay, I'm going to hit C on this. I'm going to redefine my card. Did it not? Did it not? I want to copy this. Oh, that's why. Copy. Okay, so what I'm going to do here is I'm going to define something called _rep. Okay, and what this will do is it's very similar to the string representation. Okay, except the key difference here is, rather than writing something like Queen of Clubs, is what you want to do is you want to write the command that you would use to create this object. So if we wanted to create, say, the 2 of clubs as as an object, okay, then what is the command that I would write? I would write card, I think I would write something like this, okay, card parentheses, if I wanted 2 of clubs, it would be like 0, 2, right? And so this is going to be my repr thing, I think. So if I'm going to create capital card 0, 2. So we'll call this card 1. And so I can ask card 1. Oh no, I did something. Oh, okay. I think I don't need to do that. Okay. Okay. Oh, I did it backwards. Self.suit and then self.rank should be the order. Okay, so this is what we want. So we can still call print on card 1, okay, and we'll get 2 of clubs. But then when I call what is card 1, okay, it basically outputs the exact command that we used to create card 1. Okay, so rather than getting this main.card at this, which is impossible to read, okay, when I ask what is card 1, it outputs, it is card 0, 2. Okay, basically it is the command that we use to create card 1 is what repr is going to output. Okay, so you want so repr and str are very similar in that they're both used to create human readable expressions, so you understand what this thing is, right? So str is going to be what it produces when you call print. Okay, what repr is going to do is going to be kind of the internal representation of the object, which is basically what is the command you used to create this thing. It's less readable than 2 of clubs, yet it is much more readable than main.card at 0x18. Okay, so with that in mind, let me just kind of create a new deck here. So I can do all of that again. And here, if I ask what are the vars in my hand, now it lists off, you've got card 2, 12, 2, 2, 1, 9, 1, 6, and 0, 11. So rather than getting a list of all of the kind of main.card objects, we can ask, print deck.card 0, okay, ace of hearts. What is deck.card 0? It's now going to tell me it is card 2, 1, okay, which is, I think much easier to read than, main dot, double under main or something. Okay, so that is the representation method, and that's going to basically make it easier to read through what you're doing there. Okay. All right, I'll go ahead and give you your last 2 view quiz answers, which are the letters B and C. Okay, B and C are view quiz answers 2 and 3 there. Okay, I think that will be it for today. We'll go ahead and wrap things up there, and we'll see you guys on Friday and talk more. All right, have a great rest of your day.